Alright, so let's take a look at how to solve this log problem with different bases. Alright, so the problem with this question is the bases of these logs are all different. So if the bases are different, we cannot use the log properties to write this as a single base. So what we need to do is we're going to rewrite these logarithms using the change of base formula, right? So that we can rewrite them all with the same base. Now, since the lowest value for these bases is 2, I'm going to rewrite all of these logarithms with the base 2. So this would be log base 2 of x divided by log base 2, right, of 2. All right, so this is just a change of base formula, okay? And we have log base 2 of x divided by log base 2 of 4 plus log base 2 of x divided by log base 2 of 16 is equal to 7. Okay? So the only thing I've done is I've just changed these logarithms, all right, into log base 2 using change of base formula. Now the reason why this helps you is because if you actually take a look at the denominators now, right, if you simplify these denominators, right, they're all going to become just a regular number, okay? So meaning the bottom here, I know log base 2 of 2, this is really just 1. Log base 2 of 4, this is 2, and log base 2 of 16, this is 4. So basically the problem now becomes log base 2 of x over 1 plus log base 2 of x over 2 plus log base 2 of x over 4 is equal to 7. And then now what we want to do next is we want to get rid of these denominators. So since the common denominator for these three denominators is 8, I'm going to multiply both sides by 8, right? Multiply over here by 8. So when I multiply here, I'll get an 8. I'll get 8 log base 2 of x. Right? Now the 2 and the 8, when I multiply the 8 here, right, when I distribute it here, the 2 and 8 are going to reduce and that'll become a 4. So plus 4 log base 2 of x. Then when I distribute the 8 over here, the 4 and the 8 are going to simplify, so then I'll get plus 2 log base 2 of x is equal to 56. And then now we're going to move all these exponents, right? No, sorry, move all these numbers, right, in front of the logs to the exponent spot back here. So we're going to move them all back here, right, using the log properties. And now I'm going to condense this into a single log. So now I can rewrite this as one single logarithm. This would be x to the 8th power times x to the 4th times x squared is equal to 56. Okay? So now that we have it written as a single log, what we can do next is now we can change it to exponent form. 2 to the 56th power is equal to x to the 8th times x to the 4th times x squared. And then we can add all these exponents. I'm going to get x to the, that's going to give you what, 14th power is equal to 2 to the 56th power, right? And then to simplify this, we're going to end up with, well, I'm going to raise it to the power of 1 over 14. Or you can 14th root it, it's up to you, it's the same thing. Basically what we're going to end up with over here, so we're going to end up with x is equal to 2 to the 4th power, and 2 to the 4th power we know is 16. Okay, now when you raise to the power and if your denominator is even, you have to remember to have a plus minus, right? Because this is basically the same thing as when we raise to the power of 1 over 14 is the same thing as 14th rooting both sides. So if this index is even, remember we need to have a plus minus, okay? Now, so we have plus or minus 16. Now let's verify our solutions. So going back to the original problem, if we plug in 16 and negative 16, are both of them going to be valid? So if we plug in 16 here, or here, or here, it's going to be perfectly fine, right? But if we plug in negative 16, that's not okay because we cannot have the log, all right, of some negative value, all right, that's undefined. So we know we're going to reject the negative 16 solution, right? So we're going to not include the negative 16, so our only solution is going to be x equals 16, okay? So always remember to, once you have your solutions, to double check them to see if they verify. And there are occasions where the negative value, right, would be perfectly fine, and you can include that as a solution. So you should always double check both the positive and the negative values of your solution to see if they verify, okay? All right, so let's take a look at another solving log equation problem with different bases. So since we have different bases here, we know that we cannot use the log properties to write this as a single log. So what I'm going to do is I'm going to use the change of base formula to rewrite this, right, with the same base. So since the lowest base is 2, right, I'm going to use a log base 2. So log base 2 of 3 divided by log base 2 of 8, that's going to equal log base 2 of x over log base 2 of 4. Now this is already in base 2, so I'm going to leave this as is, okay? So the reason why we do this is because now you notice these denominators right here, these will simplify and give us a whole numerical value. So log base 2 of 8, we know this is 3, log base 2 of 4, we know this is 2. So basically now the problem becomes log base 2 of 3 over 3 is equal to log base 2 of x over 2 plus log base 2 of 3. Now we don't want these denominators here, so we're going to multiply everything by the common denominator, which is going to be 6. So if I multiply this by 6, multiply this by 6, multiply this by 6, 3 and the 6 reduce, so I get 2 log base 2 of 3 is equal to, this reduces here, I get 3 log base 2 of x plus we have 6 log base 2 of 3. Now let's condense the right side, right? So we're going to end up with log base 2 of x to the third times 3 to the 6th power, and on the left side this is still, actually I'll move that 2 to the exponent spot, so I'll get log base 2 of 3 squared. And then now since we have, alright, log base 2 and log base 2, that means that we can equate these parts right here, right? So we can say that, hey, 3 squared is going to equal x to the third times 3 to the 6th power. And we know 3 squared is 9, right? And then x to the third times 3 to the 6th. So we can divide both sides by 3 to the 6th. So we're going to end up with 9 over 3 to the 6th power is equal to x to the third. We cube root both sides. We cube root both sides, right? So this will simplify out. So we get x is equal to the cube root of 9 over 3 to the 6th power. Now if this is a calculator problem, you can put this in the calculator and get our decimal. If it's not a calculator problem, then you can just leave the answer like this as is, okay? So if we actually put this in the calculator, we would get x is approximately 0.231, okay? And then if you want to verify, double check your answer, I think if we go back to the original problem, if we plug in 0.231 right here, it looks like everything is going to be fine, so it's an acceptable solution, okay?